Alright, so we're going to get going with number 1 on 4.1. It says indicate all the critical points of the graph. So we're going to draw the graph here. And when you're looking for the critical points, you're looking for the places where the slope is equal to 0. So basically, where the spots that kind of like level out, see how the slope here is like really steep, and then it gets less steep, and then it gets pretty much, and it gets to 0 right at the top there, and then it starts getting steep negative, and then getting less steep negative, and then goes down to 0 here. And so all these places where it equals, where the slope is 0, are the critical points. And this one, the first one, where I label x equals a down here, then the point f of a up here, like the function evaluated at this x equals a right up here, is the local max, because it's the highest highest point related to all the points around it. It's kind of like the apex, the top. And this one's the local min because it's like the bottom of the crest. Okay? And this last one here that I label C is an absolute max because it's the highest point on the graph, like in total. So again, critical points, all the spots where the function's slope is equal to 0. Alright. So moving on to number 3. Let's see. We can disregard this up here because this isn't what I draw. But basically this graph here has a critical point, and it has a minimum right there. So I believe that would qualify. So we can move on. Number 5. Alright. So on number 5, we're basically wanting to use the derivative to find the critical points and inflection points. Now, when you're using the derivative, you want to look at, basically take the derivative of the function and look at where either the derivative is undefined. So if you had like a 1 over x, if x were to equal 0, then it'd be undefined because you can't have 0 in the denominator anywhere, or else the function is undefined. So there's places where functions are undefined. This one is not one of those. Or you can set the derivative equal to 0 and then solve for x, and at those spots, that's where you have those critical points, because that's where the derivative equals 0. And when the derivative equals 0, remember the derivative is a representation of the function's slope. Okay? So if you set it equal to 0, you find where the slope is 0. And remember, where the slope is 0 is the critical points, like I said before in the first problem. So you set it equal to 0 and solve for x. So you add 30x squared to the other side. And then you want to divide by x squared to get all the x's over to one side. And that'll cancel out the the 2 and the 4, so that x squared is on top, and then cancels out the x squareds on the other side completely, so you have 5x squared equals 30. And then you can go ahead and obviously divide by 5, and we're just solving for x here to find the critical points, because we set the derivative equal to 0, because when the slope is 0, that's how we find our critical points. So that's all we're doing. So we set x equal, we get x squared equals 6 after dividing by 5, take the square root of both sides to get rid of the squared. So we just have x. And we get x equals, and we evaluate whatever the square root of 6 is, and we do plus or minus. Because whenever you take the square root of something, it can be either the positive or the negative, because even, if you take negative 2.45 times negative 2.45, it's still positive 6. So you get the plus or minus. And so the two critical points are x equals 2.45 and x equals negative 2.45. Alrighty. Alright, number 7, we have 5x minus 3 natural log of x. And if you go ahead and take the derivative, we get 5 minus 3 over x. And remember, when you have the x on the bottom, it can't be 0. So it's undefined when x equals 0, so that's going to be a critical point. Then we set the function's derivative equal to 0 and solve for x again. That's all we're doing. And we go ahead and get that x equals 3/5. So the two critical points here are 0 and 3/5. And you could plug x equals 0 and x equals 3/5 back into the function, and you'd see that it basically you'd get the y value, and so then you'd have a x value and a y value, and that would show you where on the function the critical points are, and that's where you'd see like those curves in the graph, like the first problem. All right.